जय हिंद एवरीवन, वेलकम टू टेस्ला एकेडमी। तो आज हम कंटिन्यू करेंगे फ्रिक्शन. It is a electromagnetic force by nature. If you see, this force is kind of contact force. And one more thing we can say about the friction, it always act opposite to relative motion or tendency of relative motion. So when we can apply the friction force when their two bodies are in contact. So applying the force, you need contact. So there should be at least two bodies which are in contact. So you can apply the friction there for friction. So you can think of this in this way. Suppose any body, it is made of atoms, and if you zoom out the surface, what happen now? You will see this kind of texture. Even at a very smooth surface also. And if you see another body which has a surface like this, so what happen? Because of these two kind of surface, when we keep there, so they are actually in interlock. So what happens here, there is kind of force of attraction here, you can see here and at this place, because of the atomic contact. And when you apply the force, this like you can see the peaks, these stops the movement of this kind of things. What happen, this produces one kind of resistance force that we call friction force actually. So this is because of interlocking of this surface. And another reason we can say, there might be some bonding between the two, any other bond. It can be like any kind of attractive force now, because these this side also there is atom and this side also there is a atom. When we talk about the friction, so in the definition we say like friction force is act opposite to the relative velocity, or when object has a tendency to relative velocity. So means it can act in two different way. One, when object is having the relative velocity, at that time we say the friction is kinetic friction. But when object is not moving with respect to each other, but they have a tendency to move, in that case static friction acts. So you can say kinetic friction when two contact surface are in relative motion to each other. इधर हम क्या बोलेंगे, tendency of relative motion. This is how we define both the force, static friction and kinetic friction. Okay, let's assume this is object A and it is kept on a rough surface, and this object is moving in this direction with velocity v. So can you tell me what will be the direction of friction force on object A and on surface?
Sir, on object A, it will be backwards, and then surface it will be forward.
Okay, good. In this way, no? Right. So this will be the direction of friction. So when we have a relative motion, in this case, there is a kinetic friction F. And we find kinetic friction as Fk is equals to mu k into N. Mu k is coefficient of kinetic friction and N is a normal reaction. So in this case, if we have to find the what is the force that is acting, for that one we can easily figure out. Let me take another question. Let's say this is an object A and it is moving on a rough surface which has a coefficient of friction mu k is equals to 0.5, and it has a mass, let's say 5 kg. So you have to tell me, like, if it is moving velocity 5 meter per second, yeah, what will be the value of kinetic friction? तो इसके लिए क्या करना चाहिए हमको? We'll first draw the free body diagram. You know, at downward there is a force that is mg, means 5g, and here at the top it is a normal reaction, say n. It is moving in this direction, velocity 5 meter per second. So friction force will act in this direction, that is Fk, and we can say the value of Fk is nothing but mu into n. So from here I can say 0.5 and value of n is 5 into 10. So we'll get 25 Newton as your friction force. Now, one more question. Suppose this is block A, this is block B, and this is block C, and all surfaces are rough. We can say here all surfaces are rough, and it is given to you this object is moving with speed, let's say 5 meter per second. This is moving with speed 15 meter per second, and this is moving with 10 meter per second. So we have to find out the direction of friction on each and every object. कौन बताएगा इस बार? सृष्टि?
Yes, sir.
Yeah.
Sir, A is moving 10 meter per second faster, like compared to B.
Yeah. So
So
in
A
this
will
one,
go forward, so friction will be backward.
very good. FK1, right? So on this one, there will be the reaction.
Yes, sir. And
Okay.
B is moving minus 5 meter per second compared to C.
Yeah.
So B moves backwards, so friction will be forward.
Okay. In this direction.
Yes.
Okay. So in this direction, we have FK2, no?
Yes.
And in the bottom one, in backward direction, right?
Yes, sir.
Okay. Good. And if you see the last reaction pair, that will be on ground. So it is FK 3. Good. So it is given to you a block of mass 10 kg. It is kept on a floor which has coefficient of friction mu is equals to 0.5, and this object is projected on this floor with a speed of 10 meter per second. So what we have to find number one, friction force and its direction. The second thing, distance traveled before it stopped, and the last thing we have to find time. So what we'll do first, we'll make a free body diagram. Okay, so let's make a free body diagram. First of all, it is moving with speed 10 meter per second. This one has downward force, that is 10g, nothing but 100 Newton. It has a normal reaction upward and it is moving in this direction. So friction force will act in this direction, that is Fk. And the value of Fk is nothing but mu k into n. So I can say that my friction force is going to be Fk, that is mu k into n. What is the value of mu k? 0.5. And what is the value of normal reaction? 100. So we'll get friction force is equals to 50 Newton. Now we can say Fk is nothing but mass into acceleration. So it is a 50 Newton and mass of object is a 10 kg, and acceleration we can find out from here. So acceleration आपका आएगा 5 meter per second square. Now here we have initial velocity and we know friction force is acting in this direction. So acceleration also will happen in this direction. So we can say retardation is happening here. So what we can say, we can apply the equation of motion. V square is equals to u square plus 2as. So you know the final velocity is going to be 0. So it is 0 is equals to, what is the u square? It is 10 square, and it is retardation is happening. So minus 2 into 5 into s. So we'll get h is equals to 100 by 10 is equals to 10 meter. And if we have to find at what time it is going to stop, so we can use the equation v is equals to u plus 80. We know final velocity is 0, initial is 10, minus 5 into t. So we'll get t is equals to 2 seconds. This angle is theta is given to you. Let me say 37 degree, and there is one object. This is fixed inclined plane. Now it is fixed, and this is a block of mass m, and initially we have projected this block upside. तो आपको ऐसा मानना है कि ये बहुत बड़ा है ना, it is very long. We have projected this thing with a 10 meter per, and the coefficient of friction is given to you. Mu is given to you 0.5. Find the time when this block will stop, then time taken to reach initial position again. This is your second part, means it will go up, then it will stop, then it will come back. So that you have to find out, that time also you have to find. तो पहला क्वेश्चन दिया है आपको, find the time when this block will stop. तो हम पहले क्या करते हैं, इसका फ्री बॉडी डायग्राम बना लेते हैं एक बार. So this is your mass m. So we'll draw all the forces. What are the forces that is acting? So in this direction it is mg, and in this direction it is normal reaction. It is moving upward with a speed of 10 meter per second. So friction force will act in this direction opposite to relative velocity. So in this direction the friction force is going to act, and we have to solve our question along this direction. So what we'll do, we'll take the component of the force. So we know this angle here will get mg cos theta, and in this direction you will get mg sin theta. Now we can say n is equal to mg cos theta, and fk is equal to mu k into n. So what is the fk? Fk is equal to mu k. Mu k is 0.5. And what is the normal reaction? Mg cos theta. So we can find out the value of this one also. The value of m is, okay, it's not given. So let's write mg and cos 37. So cos 37 is 4 by 5. So we'll get 4 by 5 into g. So we can cancel out this one now. So we'll get, okay, m also 4m. Then we know in this direction the net force that is acting. So we can say F net that is acting in along this direction, let's say x. So it is fk plus mg sin theta. So we can write here it is nothing but 4m plus m into 10 into sin theta is sin 37. So it is 3 by 5. So it will cancel out. So we'll get 10m. And now I can say F net is equals to mass into acceleration. So it is equal to 10m. So we'll get a is equals to 10 meter per second square, and it is going to be our retardation. We can use the equation v is equals to u plus at. Our final velocity is going to be 0. Initial velocity is 10 minus 10 into t equal to 0. So we'll get t is equals to 1 second. Now we have to find the total time also. So for that we can use the time of upward journey. Now we can find out the time of downward journey also. When we are going to make a diagram for downward journey, right? So what will happen? This object will have one force in this direction, that is mg sin theta, and because it is moving downward, so it friction force will act in this direction this time. So this friction force is nothing but mu k into n, that is nothing but mu k mg cos theta. So we can say this time or F net is equals to mg sin theta minus mu k mg cos theta. We'll put the value now. M into G is 10, the sin theta is 3 by 5 minus mu k is 0.5 into M into G is 10 and this one is 4 by 5. So when you solve this one, what you will get? You will get 2m only. So we can say F net, that is 2m, is equals to mass into acceleration again. M will cancel out, so we'll get acceleration is equals to 2 meter per second square. So what we have to use? We have to use this time the equation A is equals to ut plus half at square. We know initial velocity is 0, but we don't know this displacement. So what we'll do? We'll use again the previous one to find out the S. So how we can find out the S? Using the equation again. S is equals to Vt minus half A. This is also an equation of motion. We know the final velocity is 0. So we can say S is equals to 1 by 2 and our retardation was 10 only and the time is 1 second. So we'll get 5 meters. So we can use this thing here. So 5 is equals to 1 by 2 and acceleration is 2 into t square. So you'll get t is equals to root 5 second. So your total time, that is time of up the incline plus time of down the incline, is equal to 1 plus root 5 second. Static friction. So we have to find like when this static friction is going to. So in the definition we was having the two words. One is the relative motion and one is the tendency of relative motion. Suppose if there is any tendency of relative motion and surfaces are rough, then there will be static friction. So in this case, you can say no relative motion between contact surface. Then what we can say about the static friction. So जब हम static friction की बात करेंगे, we have to find the two values. ना, one is the magnitude and the second one is direction. So for finding the magnitude, so quite simple. Na, if we have to find the magnitude of static friction, it is nothing but mu s into normal reaction. And for finding the direction, you have to find where the force is acting on the object. Suppose this object is kept on the rest on this surface and this object is at rest. This has the mass m. So suppose if you are applying force in this direction, but it is not moving, it is at rest. So it has a tendency to move in this direction only. So friction force will act in this direction, static friction. Similarly, if you push this block like this, so what happen in this case? The friction force will act opposite to the tendency of relative motion. So here, the direction of friction force is going to be like this. Suppose there is an object. It is kept on a rough surface. It has a mass m, and this is our contact surface. Let's say this surface is a rough surface, and we are applying force in this direction, like this. Let's say this is our force. This is your force if that is we are applying in this direction, right? Initially our force is let's say this time we are taking this force is time dependent. Let's say force is time dependent, and for sake of understanding, let's say force is equals to some magnitude. So so k into t. So when we are going to apply this force, what is going to happen? So let me draw this thing on the axis. So this is my y-axis and this is my x-axis. On y-axis I'm going to take the friction force, static plus kinetic both. Here is what friction force and here is our time. So you know, as soon as I increase this force, so suppose this object is kept at rest and the value of F is 0 and this has a mass m. So in this case, the friction force that is going to act is a 0 because it is going to oppose this force and the tendency of relative motion. So initially we can say our force is 0 here. As you increase the time, so the value of force is also going to increase. So what happened? Our force is increasing, static friction is also increasing. Now there will be one time when for value of force that you are applying will be more than maximum value of static friction. And how we can find out the maximum value of static friction? So for finding the maximum value of static friction is mu s into normal reaction. This is for the maximum static friction, this formula. If there is not a like maximum static friction, then static friction can be anywhere from 0 to maximum value. Then what happen after this? If you still keep increasing your force, so what happen? Suddenly the peak will come and this will be your kinetic friction. But for our question, we generally don't take like this. We simply take like this. So here your static friction, and in this yellow region it's a kinetic friction. Because after this point, what will happen? After this point, right, if you keep on increasing your force, then in that case your F net is going to be F minus Fk, and that will be your mass into acceleration. So your block will move. Now here is a one term that we are using, coefficient of friction. So if you see generally coefficient of friction, na, it depends on material. And if you see the friction force, it is nothing but the mu into N. So friction force depends on coefficient of friction. So coefficient of friction means material, and the second thing is the normal reaction. Suppose if in the question they are asking friction force depend on the like contact surface area, so that statement will be false. Friction force does not depend on contact area, or you can say friction force does not depends on area of contact, because there is no term of area in our form. So you can simply say it is independent of area of contact. Now we'll solve some question on this one. It is given to you, there is a block that is kept on a surface, rough surface, and it has a mass m equal to 10 kg. And on this one, we are applying a force F is equals to 50 Newton, and the coefficient of friction mu is equals to 0.5. The question is that find acceleration of block. तो चलो हम इसको solve करते हैं ना. हम इसका free body diagram बनाते हैं एक बार. So we know on this direction that force is acting is the F is equals to 50 Newton, and you know the downward force is mg, that is 10 into g, and upward force is normal reaction, and we know upward force equal to downward force, so you can say n equal to 10g, that is nothing but 100 Newton. And if you see the friction force on this one, so we'll see here it's 50 Newton, and here you try to figure out fs max, so that will be 0.5 mu into and n is 100, so it will come 50 Newton. So our maximum friction force is acting backward direction, that is 50 Newton. So I can say F net is equals to 50 minus 50 is equals to 0 is equals to mass into acceleration. So acceleration will also be 0. आपको दिया हुआ है क्वेश्चन में कि there is a block of 10 kg and it is kept on a rough surface, and on this one the force is acting is a 51 Newton and surface is rough. This time it is given to you the coefficient of static friction is 0.5 and coefficient of kinetic friction is 0.3. आपको क्या करना है, initially block is at rest. What do you have to do? Find acceleration of block. So what we will do in this question, first we will see what is the maximum friction, static friction that can act, because initially it is at rest. So we'll see the fs max possible, that is mu into n. What is the value of mu s? Mu s is nothing but 0.5. And what is the normal reaction? So normal reaction will be 10g, and here it's a normal reaction, so it will be 100 Newton. So we'll get fs max is 50 Newton, and your force is acting is a 51 Newton. So your block will move. When your block will move, at that time, the friction that is going to act is a kinetic friction. And value of kinetic friction is what? Fk, that is mu k into n. The value of mu k is 0.3 and n is 100 Newton. So it will be 30 Newton. Now we know F net. Net force that is acting on our block is what? 51 minus 30, that is m into a, that is nothing but 10 into a. So you'll get 21 by 10 is equals to a meter per second square, or 2.1 meter per second square. This is a fixed inclined plane. It is forming an angle of 37 degree, and this is rough surface which has the coefficient of friction 0.5, and here is a block of mass 10 kg, and here we are applying the force 75 Newton. And initially the block is at rest. You can say initially block is at rest. What you have to do? You have to find acceleration of block. Make the free body diagram. So let's take this 10 kg block. On this one, the 75 Newton force is acting in this direction, and you know mg is acting in this direction, that is 10g. And now we'll see the static friction in which direction it is going to. So for that, what we'll do, we'll first take the component of this mg. So if we take the component of mg in this direction, we will get 10g sine 37, and in this direction you will get 10g cos 37, and here you'll get normal reaction. So your normal reaction is nothing but 10g cos 37 degree. So you'll get 10 into 10 into cos 37 is 4 by 5. So 2. So normal reaction will be 80 Newton. Similarly, you take this one. 10g sine 37. So what you will get? So let's calculate this one also. 10 into 10 into 3 by 5. So this will cancel out 2. So we'll get 60 Newton. So on this direction, the net force is 60 Newton. That is because of mg sine. So here we have only 50 Newton force extra. So what will happen in this direction? The friction force that is going to act static, and that is only 50 Newton. And maximum value of friction that can act here, so F makes that possible, it is mu into n. So it is 0.5 into n is 80, that is 40 Newton. But in our case, only 15 Newton of force is going to be applied, because static friction can change its value. Now it can vary from 0 to maximum. Therefore, our net force on this object is going to be 0. So acceleration is going to be 0 only in this case also. We'll do one more question. This is a top view of a table, and this is a block of 10 kg. And here you are applying the force of 40 Newton, and here you are applying the force of 40 Newton. The coefficient of friction is given to you, mu is equals to 0.5. Find acceleration of block. This is a top view. Okay, this is what you are seeing from the top. आपको पता है इसके ऊपर नेट फोर्स कितना एक होगा? फर्स्ट ऑफ ऑल तो यहाँ पे 40 न्यूटन है, यहाँ 40 न्यूटन है, तो इसका रिजल्टेंट फोर्स यहाँ आएगा, दैट विल बी रूट ओवर 40 स्क्वायर प्लस 40 स्क्वायर, दैट विल बी नथिंग बट 40 रूट 2 Newton. Now if you see this from a side view, so what will happen? You will see this 10 kg block in this direction. There is net force that is acting 40 root 2, means we are seeing along this axis. So what happened here? The like gravitational force, that is 10g. Here it's a normal reaction, so we can say normal reaction is equals to 10g is equals to 100 Newton, and in this direction friction force is going to act. So what is the value of friction force? That is mu into n. So we write here F is equals to, the value of mu is 0.5 and the value of n is 100 Newton. So we'll get your friction force, obviously kinetic, that is 50 Newton. So your F net this time is going to be 40 root 2. If you calculate this value now, 40 root 2, it will be more than 50x. So minus 50 Newton, that is the friction force. So this net force is going to be mass into acceleration. The mass of the block is 10 kg into acceleration. So you can say acceleration of block is 4 root 2 minus 5 meter per second. So let assume this is one block which is kept on a smooth surface, and there is another block which is kept here, and it has a mass of 10 kg. This block has a mass of capital M, and the coefficient of friction is given to you 0.5, and it has the acceleration a here. So what you have to do? Find minimum value of A so that block does not fall. So which block is not going to fall? This block. So what we'll do? We'll make a free body diagram of 10 kg block. So on this one, downward force, that is mg, going to act. That is nothing but the 10g. And if you see, we are going to apply here our pseudo force. Means you are standing here. So you are moving with the block, and block is in rest with respect to you. So what happened? In this direction, the pseudo force is going to act. And what will be the value of pseudo force? M into A. And what is the value of M? Is a 10. So we can write 10A. In this direction, the normal reaction is going to act. And normal reaction is nothing but equal to 10A only, because this is our contact surface. Similarly, if you see the friction force that is going to act here, there is nothing but the mu F is equals to mu into N. And what is the value of mu? 0.5. And what is the normal reaction? It is 10A. So we'll get 5A, 5A as our friction force, and we can say 5A should be equal to 10g. Why? Because this block is that does not moving with respect to this bigger block. So we can say from here A is nothing but 2g. That will be equal to 20 meter per second square. It is a rough surface. देखो आपको इस क्वेश्चन में दिया हुआ है, it is given to you. These are two block of mass 10 kg and 20 kg. It is kept on a rough surface, and on this block we are applying force here 100 Newton and here 120 Newton. And it is also given to you this time the value of maximum friction that can act here. That is nothing but 90 Newton in case of 10 kg block, and in case of 20 kg block it is a 60 Newton. So what you have to do? You have to find tension in the string. So let's see what can happen. So let's assume this is our first block. Now it is connected to another block with the help of a string. Here we are applying a 100 Newton force, and here we are applying a 120 Newton force. Now assume this system is like this is the 10 kg and it is a 20 kg. So assume this block will move this side. We are assuming now. So what will happen? The friction force on this one will act in this direction, that is 90 Newton, and friction force on this block will also act in this direction, that is 90 Newton. So we have assumed our acceleration in this side. Now see what is our F net. So it is 90, 150 and 100. So 250 minus 120. So our F net is coming in this direction. So now it is not possible. So what we'll do for our second case, we'll assume this block is moving towards. Let's assume this system is moving this side. Okay. This side, the system has the acceleration A. Now this force is 100 Newton. This force is 120 Newton. And so friction force active in this direction backward. And here it's also backward, 90 Newton. So now we know our net force is going to be backside, this side now, no? Because it is 120 plus 90 plus 60. And in the front, it is 100 you see as a system. So that is also not possible because net force in this direction, acceleration in this direction. So now we have got, like we have understood one thing from here. So system should be in rest, right? Now make that diagram. Here it's a 120 Newton and here it's a 100 Newton. And assume that our maximum friction is acting in this block. So 120 is acting in this direction. So let's assume 90 Newton acted in this direction. So from that we can say our tension. If we calculate our tension, how? T plus 90 is equals to 120. So T is equals to 30 Newton. So T is coming to with 30 Newton. Now, if you see this block, so in this direction, the force is acting 100 Newton and the tension will again act here 30 Newton. So what will be the value of friction force remaining? So if you see the remaining force is going to be in which direction? This direction. And how much it is? Should be 70 Newton, but our maximum value is only 60 Newton. So it is also not possible. So this case also we will discard. Now we'll see the last possible. So what can be happen next? This is again our block, two block. Okay, here it's a 120 Newton and here it's a 100 Newton. Now we'll assume like maximum friction acting on this block. So it is a 60 Newton. So now here it's our tension. So if you see T plus 60 is equals to 100, so T is equals to 40 Newton. Now if you see this block, so on this block tension will act in this direction, that is 40 Newton, and friction force will also act in this direction. So the value of friction is going to be 120 minus 40 is equals to 80 Newton, and our maximum value is 90. So now it is permissible. So this will be our answer. The value of tension will be 40 Newton. ये आपको एक क्वेश्चन दिया हुआ है. In this question, this man is applying force F on this block. So what you have to find now? You have to find the this surface is rough and this surface is smooth. You have to find normal reaction between wall and block capital M, and this F is much larger than the friction force of both the blocks. Then what we are assuming, whatever the friction force will from that value, this F is going to be larger. So you have to find the normal reaction between the wall and the block. So what we'll do is first make a free body diagram of block small m. So this is our small m. Downward there is a one force that is acting mg, and here it will be normal reaction, let's say 1. And you are applying force F here. So the normal reaction from the capital M will act in this direction. Let's say it is N2. And because you are trying to move this object in this direction, so what happened? The friction force will act in opposite to that, means in this direction. So this will be your friction force, and that will be mu into N. Now we'll make a free body diagram for a capital M. This is our capital M. Downward force that is acting capital M into G. Upward force that is acting is a normal reaction 3. In this direction, normal reaction 2. And in this direction, that what we have to find the normal reaction 4. And since this object will try to move in this direction, so the friction force will act in this direction. So friction force, let's say 2. If that is mu into N3, here mu into N1. Na? So value of F, what you will get? Mu, and the value of N1 is nothing but mg. Similarly, the value of F, let's say this one F1. So mu into N3, and the value of N3 is nothing but capital Mg. So from here, if we make the horizontal like equation in horizontal direction, or yeah, along the x-axis, so we can say F is equals to N2 plus mu into N1. And now we'll put the value N2, let it be there. So the value of N2 is going to be F minus mu N1. The value of mu N1 is what? Mg only, mu Mg. Similarly, we'll make the equation on capital M in horizontal direction. We'll get N2 is equals to mu N3 plus N4. Now you know the value of N2 is F minus mu small mg, and mu, the value of N2 is nothing but capital M into G plus N4. So we'll get N4 equal to N minus mu mg minus mu capital M, or we can say N4 is nothing but F minus M plus M into G. So the question is that this is a block. It has a mass of 10 kg, and on this one we are applying a force. The value of force is F, and this angle is theta, and the value of theta is 37 degrees, and it is kept on a rough surface, and the surface has a coefficient of friction mu A is equal to mu K is equal to 0.5. आपको ये बताना है, determine whether the block will slide or lift first. What is the thing is given to you? F is increasing gradually. So you can say F is nothing but something like K into T, which is like function of time. So you have to decide this thing, whether it's going to lift first or slide first. We'll solve this question. तो हम क्या करते हैं, इसका free body diagram बनाते हैं first. We'll draw the free body diagram. You know, downward there is one force acting, that is 10g, that is nothing but 100 Newton. Upward there is a normal reaction, and this force is acting in this direction. So it is going to have a two component, one in this direction, F. So this will have F cos 37, and one will be in this direction, right? Upward. So that value will be F sine 37. Now, the friction force is also going to act, and it will act in this direction, and this friction force is going to be mu into n. Initially it is at rest, so I am considering the static friction. Now, so first we'll make equation vertical. So what is that? I can say n plus F sine 37 is equals to 100 Newton. So suppose if I want to lift this object, so what should be there? This normal reaction must be there, because when we are going to lift the object, the normal reaction will be 0. So I can say F is equals to 100 by sine 37, that is 100 by 3 by 5, that is nothing but 500 by 3 Newton. So this is the value of force that is required for a lifting. So this force you can say F required for lifting. Now we'll see what is the force required for the sliding. So what we'll do, we'll make again the same equation, n plus F sine 37 is equals to 100 Newton. So this time we are not going to put this normal reaction equal to 0. What we'll do, we'll find the value of normal reaction. So that is 100 minus F sine 37. Now we'll apply the equation horizontal direction. So you can see the force in horizontal direction, this one and this one. So I can write F is equal to mu into n, and that will be equal to F cos 37 for all limiting case. So we'll see what will be this value for the lifting. So let's say F cos 37 is 4 by 5, and mu, and the value of n. The value of n is nothing but 100 minus F sine 37, that is 3 by 5. So 4 by 5 F is equals to 1 by 2, that is 0.5 into 100 minus 1 by 2 into 3 by 5 into F. So you'll get 4F by 5, and take this term to the left side. So plus 3 by 10 F is equals to 50. So from here, so 8 plus 3 is 11. F is equals to 50. So we'll get F is equals to 500 by 11. So this force is for sliding. This is what we're doing for the sliding. So you can see the F lift was 500 by 3, and F slide is 500 by 11. So we can see here F sliding is lesser compared to lifting, and we know our force is gradually increasing. So what happened? Sliding will happen first. Sliding will happen first. Okay, so we'll start two block problem. So let's assume we have one block. It is kept here, and it has a mass 10 kg. And let's say this block is A. There's another block, and its name is B. And let's say it also has a mass 10 kg. This surface at the bottom, it is given to you. It is a smooth surface, and this is a rough surface. It has a coefficient of friction 0.5, and we have applied 50 Newton force on this object. F is equals to 50 Newton, and our system is initially at rest. So what do we have to do? We have to find acceleration of block. So what we'll do first, we'll make a free body diagram for each block. So let's make for a 10 kg block A. So in this one, the F is acting in this direction, 50 Newton, and the friction force will act in this direction. So let's say it is F1, okay, and mg will act in this direction, that is 10g, and here it will be normal reaction. So I can say F1 is nothing but mu into n, and the value of mu is 0.5, and the value of n is 100 Newton. So you'll get F1 as 50 Newton. So if you see this block, what will happen? The net force on this block is going to be 0. So F net on block A is what? 50 minus 50, that is 0. Now we will draw the free body diagram of block B. So this is our block B. It also has a mass 10 kg. This bottom surface is smooth, so it will act in this direction, that is F1, and this bottom surface is smooth, so no friction force will be there. Right now, what happened in this block? If you write F1 is equals to M1 into A, so you'll get A is equals to F1 is 50 by A is 10 kg. So you'll get 5 meter per second square. So is it possible to get such kind of acceleration? Because what is happening now? You are applying force on block A, and the acceleration is happening on block. So it is not possible at all. Whenever you apply the force on an object, it is going to have a more acceleration compared to the object with which it is in contact, right? So our acceleration of A is 0, and acceleration of B of 5 meter per second square. So acceleration of A cannot be less than the acceleration of B in this case. Why it's not possible? Because we are applying the force on a which object? Object A, not on B. So it is not possible that object A does not move and object B will move. So what is the possibility then in this case? We can say our friction is not maximum in this case. So what happened? When such kind of situation arise, what we will do, we'll make both the object again, and this time these two blocks will move together. This is the only possibility, because all the force that we have applied is on object A, and that force is 50 Newton. So what we can say here, that is F on system is equals to m1 a1 plus m2 a2. You know the total force that F is 50 Newton, M1 is 10 kg into A1. You can say A plus 10 into A2, and A2 is also equal to A1. So from here we can say A1 is equals to 50 by 20, that is 2.5 meter per second square. If you have to find the friction now, you make this block A, and on this one the force is 50 Newton. I am assuming the friction force will act on this direction. Okay, and it has acceleration here, that is 2.5 meter per second square. So I can say 50 minus Fs, and this time F is not equal to mu into n, because we are not taking the maximum friction, because static friction can change its value from 0 to maximum, but kinetic friction is always fixed. So I can say it is mass into acceleration. My mass is 10 kg and acceleration is 2.5, so I'll get Fs as a 25 Newton. So what you can see from here, if you draw the graph, okay, so what is the maximum possible value of friction? So let me say here you are applying the force F, and here is a friction force. So it will move like this, then it will become horizontal. So this maximum possible value is 50 Newton. But in our case, because this is the range of static friction, so this is a static friction range. So static friction can vary from 0 to 50. So this time it is 25 Newton. So on this block, it is backward on A, and if you see on B, it is acting in this direction. That is 25 Newton. This is your table, and on this one you have kept some object, and you tied this thing with the string, and the surface is sufficiently rough now, and you are pulling this object. So is it possible that this block will not move and this table will move?
No, sir.
No, no. The only possibility, either this block will move or this both the thing will move together. तो ये move साथ में जब move हो रहा है ना, मतलब कि there is no relative motion between A and B, right? No relative motion between A and B. So what happen in this case? That case, when it does not have a relative motion, in that case static friction is going to act, and the value of
Yes, sir.
static friction can be vary from 0 to mu s into n. इसी क्वेश्चन को हम कंटिन्यू करते. So this is block A and this is block B again, and this is kept on a smooth surface. This surface is rough, it has a coefficient of friction 0.5, and both the block has the mass of 10 kg 10 kg, and this time we have applied a force F is equals to 101 Newton. So what you have to do again? Find acceleration of block A and B. So what you have to see first? You have to see whether they are going to move together or move separate. Suppose if they are going to move together, so for that the acceleration is very easy. You can say acceleration is nothing but F net upon total mass. There's mass of A plus mass of B. So 101 by 20. So we'll get 505 meter per second square. But we have to see whether they are going to move together or separately. If we have to, this is the condition when they are going to move together, right? But if you see block B, okay, so if you see the block B and this block A also, on this one the force that is acting 101 Newton, the maximum friction that can act on this one is a 50 Newton backward, and the this block is 50 Newton forward. So from here I can say, if I have to find the acceleration of A, so what we can say, F net, that is 101 minus 50 is equals to 10 into A, acceleration of A. So we can say acceleration of A is nothing but 51 by 10 is equals to 5.1 meter per second square. And the next case is the acceleration of B. So on this one only friction force is acting, right? And it is acting at the maximum value. So friction force will be 50 Newton, and it will be mass of block B, that is 10 into acceleration of block B. So we'll get acceleration of block B as 5 meter per second square. Now this time acceleration of A is greater than acceleration of B. That is possible. And acceleration of B cannot be more than 5 meter per second square. Why? Because the maximum force that can act on a block B is only 50 Newton. That's why they will not move together. They are going to move separate. And this is their acceleration. Acceleration of A is 5.1 and acceleration of B is 5 meter per second square. These are two blocks. One is 10 kg, another one is 20 kg, and they are kept on a smooth floor. The contact between A and B is rough, and it has a coefficient of friction mu, that is 0.5. And we have applied the force 60 Newton on this block. What do you have to do? You have to find acceleration of block A and acceleration of block B. We can assume two cases now. One is that when they are moving together, and one is that when they move separately. We have to check both the cases. So when they are moving together, this is the easiest one. That's why doing it first. So we know in that case the F net is going to act as a 60 Newton, and the mass of object is 10 plus 20, and acceleration is common for both the object because they are moving together. So from here you will get acceleration 60 by 30, that is equal to 2 meter per second square. So this acceleration for both the block A and block B, that is 2 meter per second square. But there is another possibility. What? When they can move separately. So what happen in that case? We have to draw the FBD again. So this is your block. On this one, the force that is acting is a 60 Newton. You know, when they are moving separately, means the sliding is happening between them. So maximum friction will act here. that is mu into n, and we have calculated already this one, that is 50 Newton, right? So I can say F net that is acting on this block is 60 minus 50, and that will be mass into acceleration of block A. From here you'll get acceleration of block A is equals to 1 meter per second square. Similarly, you'll make this same diagram for block B. So you know on this one, this friction force will act forward, and this force is nothing but 50 Newton. So you can say F net is equals to mass into acceleration of B. In this case, the 50 Newton is only force that is acting on block B, and mass of block B is 20 kg, and acceleration of block B is that we have to find. So I can say acceleration of block B is nothing but 2.5 meter per second square. Now what we see here, we see here acceleration of A is less than acceleration of B, which is not possible because we have applied force on object A. So this case is not possible. So it is not possible. So what will happen then? They will move together and acceleration will be 2 meter per second square. मान लो ये block है आपका, the block of mass 10 kg, and this block has a mass of 20 kg. It is kept on a smooth surface, and this surface is rough. We have applied the force F. You have to find limiting value of F for which sliding will start. So what we'll do, we'll make a free body diagram first. So you know, on this one, force F is acting, and in case of maximum friction, that is going to be act here Fs, and that will be mu into n, that is 50 Newton. And if you see block B, so on block B, this 50 Newton is going to act forward. So in limiting case, what will happen? Till the end, these two blocks will move together. Then the sliding will start between A and B. So we'll see that limiting case. Okay. So what happened? F minus 50 is equals to mass of A into acceleration of A. Similarly, you will see for object B. So what will be there? 50 is equals to mass of B, that is 20, into acceleration of B, right? And we know acceleration of A and B should be equal for limiting case. So acceleration of B is equals to 50 by 20, that is 2.5 meter per second square. So acceleration of A should also be same in that case, right? So I can say F minus 50 is equals to 10 into acceleration of A is 2.5 meter per. So we'll get F is equals to 75 Newton. This block is 10 kg, this block is 20 kg. The surface is rough again, and it has a coefficient of friction 0.5. This surface is smooth. And this time we applying force F on object B. So what you have to find in this case, find minimum value of F for which sliding will happen. So what we'll do, आपको पता है कि फिजिक्स में कोई भी प्रॉब्लम सॉल्व करने का पहला तरीका क्या है? Always draw free body diagram. So this is block A and this is block B, and you know they have a mass 10 kg and this has a mass 20 kg. On this one 10G will act here, that is 100 Newton, and here it will be normal reaction. And on this block we are applying force in this direction, right? So on this block the friction force should act in this direction, that is your friction, and in this block friction force will act in this direction. So what is the maximum possible value of this friction? That is mu into n. The value of mu is 0.5 and the normal reaction is 100 Newton. So you'll get 50 Newton as your friction force. So here you can put the 50 Newton. Now, if you see the acceleration of block A, or you can apply the equation of block A. So what you can see, the friction force will be equal to mass into acceleration of block A. So friction force is a 50 Newton. The mass of block A is a 10 kg, and acceleration of A from this one is A is equals to 5 meter per second square. Similarly, we'll apply the same equation on block B. So what it will be there? F minus friction force, and that will be mass of block B into acceleration of block B. And we know for limiting case, like acceleration of block A cannot be more than acceleration of block B. So for limiting case, they will move together. After that, sliding will happen. So acceleration of B will be more compared to acceleration of A in this case, right? Because we are applying the force on block B this time. So what we can see here, F minus Fr. What is the friction force? The friction force is 50 Newton, and mass of block B is 20 kg, and acceleration of block B must be equal to the acceleration of block, because it cannot be less than the acceleration of block A this time. So it will be 5 meter per second square. When you solve this one, you will get 100 plus 50. So F is equals to 150 Newton. So if your force is less than 150 Newton, so these two blocks will move together. And if your friction force is greater than 150 Newton, then acceleration of block B will be acceleration of block A. So let's solve one question, and we'll take separate case in this. So this is block A and this is block B. Block A has a mass of 10 kg and block B has a mass 20 kg. The surface between block A and B is rough, and coefficient of friction, that is mu h is equals to mu k, and that is given to you 0.3. This surface between the block B and ground, this surface is smooth. Here we have applied total force F is equals to 120 Newton, and here we have applied force F. We are going to take separate cases for the value of F, and then we'll try to figure out the acceleration of block A and B. So what we have to do? So we'll take the value of F. Corresponding to that, we'll find the value of acceleration of block A and acceleration of block. So first, it is given to you the value of F is equals to 0. So you have to find the acceleration of A and acceleration of, let's say this block is 10 kg. So we'll make a free body diagram. You know, downward there is a 100 Newton force is going to act. Upward is a normal reaction. This side force is 120 Newton, and this side, let's say what is going to act with the friction force. Now we can say later friction force. So the value of this friction force, how we can find out value of F? Mu into N. The value of mu is given to you point, and value of N is given to you 100 Newton. That we can figure out from here. N equal to 100 Newton. So we'll get friction force is 30 Newton. If you draw the free body diagram of a block B, so you know on this one the friction force will act in this direction. It will has the acceleration, let's say A, B. So you can say F is equals to mass of B into acceleration of B. Now you can see from here, if you find F net on block A, so what it will be? 120 minus 30 Newton, and that will be equal to mass into acceleration of A. The net force that is acting on A is a 90 Newton, and mass of A is 10, and acceleration of A is that we have to find. You will get acceleration of A is equals to 9 meter per second square. Similarly, if you solve same way for blocks, you will get F is equals to, that is the friction force now, 30 Newton is equals to 20 into acceleration of B. So we'll get acceleration of B equal to 1.5 meter per second square. Now we can see here the force is acting on block A, and the acceleration of block A is more than the acceleration of block B, which is possible. So we can say the acceleration of A can be greater than equal to acceleration of B here, and the maximum friction is already acting. So we can say the acceleration of A is nothing but 9 meter per second square, and acceleration of B is 1.5 meter per second square. Let's take the value of A is equals to 120 Newton. Then again you have to tell me what will be the acceleration of A and B. So again what we'll do, we'll make the free body diagram. Let's take this is block A, and this is our block B. On this one, 120 Newton is acting in this direction. On this one, 120 Newton is acting in this direction. So let's assume maximum friction on this one is applying in this direction. We can assume in forward direction also, no? But in the previous one we have assumed backward, so in this one also I am assuming backward only. So it will be mu into N, and that will be equal to 30 Newton. And on this one, this force is going to act forward, that is 30 Newton. Now we'll see the equation on A in horizontal direction. So what is the net force? That is 120 minus 30. It will give you mass into acceleration. So mass of A into acceleration of A, that is nothing but 10 into acceleration of A. इसको आप solve करेंगे, so you get A is equals to 9 meter per second square again. Similarly, if you solve for B, right? So what will happen? The net force that is acting on B is 120 plus 30. So it is 150 Newton, and it will be equal to mass into acceleration. So mass of B is 20, and acceleration of B is, let's, that we have to find. So when you solve this one, you'll get acceleration of B is equals to 7.5 meter per second square. So this is possible. Yeah, this is possible now because our maximum friction is acting, and sliding will definitely happen. You can say the acceleration of A is 9 meter per second square, and acceleration of B is 7.5 meter per second square. Now let's take the third case where your this force is 150 Newton. Again, you have to find the acceleration of A and acceleration of B. So again, what we'll do, we'll make a free body diagram of A and free body diagram of object B. So you know on this one, the force is acting as a 120 Newton, and on this one, the force that is acting is a 150 Newton. On this one, let's assume the friction force is acting backward. So F will be your 30 Newton, and on this one, it will act forward, that is 30 Newton. So if you see the net force on block, so it will be 120 minus 30, that is 10 into acceleration of A. यहाँ से आपको मिल जाएगा acceleration of A is 9 meter per second square. सेम हम क्या करेंगे, जो इक्वेशन हमने A के ऊपर लगाया, सेम तरीके से हम इक्वेशन किसके ऊपर लगाएंगे, B के ऊपर लगाएंगे. The net force that is acting on B, right? It is 150 plus 30, and mass is 20 into acceleration of B. So from here you will get acceleration of B is equals to 180 by 20, that is equal to 9 meter per second square. So it is possible. Yes, it is possible, and both the object has the same acceleration. So it also has a 9 meter per second square, and it also has a 9 meter per second square. If you see this one, here the relative motion is happening. So the friction that is acting here is a kinetic friction. Here the relative motion is happening when we applied the force 120 Newton. So here the force is also is kinetic friction. But here the relative motion is not happening. The acceleration of both A and B is same. That's why we can say here static friction will act, and it is acting at a maximum value. Let's take the value of F is equals to 180 Newton. Then you have to find the acceleration of A and acceleration of B. Now we'll try to solve it again. So what we'll do, first step, we'll make a free body diagram. Block A, on this one the force is 120 Newton, and on this one, let's say this time our friction force that is acting is a F. Okay, we haven't taken the maximum value. We can take the maximum value also, not a problem. And here it's a B. On this one, the force that is acting is a 120 Newton. On this one, the force that is acting, friction force is a F. Suppose if you take this one as a maximum value, then what happen? This value will be 30 and this value will be 120. जैसे कि अगर आप ए के ऊपर नेट फोर्स देखोगे, so what will be the net force on A again? It's a 120 minus 30, that is 90, and we'll get acceleration again is 9 meter per second square. But if you see the object B, what happened with this one? So for object B, you will see net force that is acting on this one is a 210 Newton, and let's say mass of this one is 20 and acceleration that is B. So we'll get from acceleration of B is how much?
So 10 point.
Yeah, 10.5 meter per second square. If you see here, this is the acceleration of B. So that is 10.5 meter per second square. And here, the acceleration of A, that is 9 meter per second square. So in this case, what is happening now? The relative motion, where the relative motion is happening. So if you see, the acceleration of B with respect to A is what? 10.5 minus 9, that is equal to 1.5 meter per second square. So relative motion is happening in this direction, and we are applying the friction force also in this direction. So is it possible? No. The friction force always act opposite to relative motion.
Yes, sir.
So this case is not possible. So what will happen when they are not moving separately? So what will happen in that case? They will move together. K, relative motion and friction force. Friction force, which friction force? Kinetic friction, right? Kinetic friction force cannot have same direction because they always act opposite to each other. So now they are not moving separately. So what we can assume? We can assume they are moving together. So let's assume this block A and this block B. And on this one you have applied the force 120 Newton. And on this one we have applied the force how much? It's a 180 Newton. So if you see what is the net force that is acting on this one. So this time it is 300 Newton, 180 plus 20, and it will give you total mass. Mass of A is 10 plus mass of B is 20. We have applied the equation of system here. No? F system is equal to M1A1 plus M2A2 plus M3A3, like that. And we have assumed these two blocks are moving together. So let's say acceleration A. If you solve this one, you'll get acceleration 300 by 30. That is 10 meter per second square. So is it possible? Yeah, it is possible. If it is possible, then what is the value of friction that is going to act? So that we will see. So again, we'll draw the free body diagram of B. On this one, the force that is acting is a 120 Newton. Okay. And it has an acceleration A. And let's say we don't know the direction of friction where it's acting. So I'm simply assuming the friction force as a F. Now I can say F net. So what is the net force on this one going to act? 180 plus F, and that will be equal to mass into acceleration. Mass of this one is 20 and acceleration that we got is a 10. So if you solve this one, you will get friction force as a 200 minus 180. That is 20 Newton. So is it possible that 20 Newton friction force can act? Yeah, it's a possible. When it's possible? When it is a static friction. So हम बोल सकते हैं how much we got? 10 ना? So we can say this time they are going to move 10 meter per second square, and this one also 10 meter per second square, and friction is static, but it is not a maximum this time na. It is going to act as a 20 Newton only in this case. Now let's take the another case. This value is 240 Newton. Again, you have to find the acceleration of A and acceleration of B. So again, what we'll do? We'll make a free body diagram. So we'll make a free body diagram of A. Okay. On this one, the force that is acting is a 120 Newton, and the free body diagram of B. On this one, the force that is acting is a 240 Newton. And let's assume they are moving separately. So let's assume the maximum friction is acting in this direction, that is 30 Newton, and on this one again 30 Newton. So you will get here the net force 90 Newton, that is equal to mass into acceleration of A. So from here again you will get acceleration of A is equal to 9 meter per second square. Similarly, you apply the same equation on object B. So you'll get net force 270 Newton, and that will be mass into acceleration of B. So it will be 20 into acceleration of B. So you'll get acceleration of B is equal to 270 by 20, that is 13.5 meter per second square. Now we will see here that acceleration of B is here, that is 13.5, that is B, and A has acceleration here, that is 9 meter per second. So we can see acceleration of B with respect to A is what? 13.5 minus 9. So that is equal to 4.5 meter per second square. So relative acceleration happening in this direction, right? So here the relative acceleration and the force is also acting in this direction, friction force. That is not possible because friction force act opposite to the relative motion. So this case is not possible. So we will assume like our block A and block going to move together. So on this one 120 Newton, on this one 240 Newton. So we'll apply F system, that is 120 plus 240 is equals to 10 into acceleration of A, let's say A only, and 20 into acceleration of B, say A only, because we have assumed they are moving together. So what will happen in this case now? It will be 360 is equals to 30 into A. We'll get A is equals to 360 by 30, that is 12 meter per second square. Now we'll try to find out what is the friction force that is acting. So we'll see, if you see object A only itself. So what happened? On this one, 1 Newton, 120 Newton force is acting. And let's say friction force that is acting here, let's say F1. So we'll say 120 plus F is equals to how much? It will be mass into acceleration. Mass of block A is a 10 and acceleration is a 12. So this 120 will cancel out and you get friction force as a 0. So what happened in this case now? We can say acceleration of both the block will be same and friction that is acting here is a 0. Now let's take this force as a 300 Newton, and again you have to find the acceleration of A and acceleration of B. We'll make a free body diagram of A and we'll make a free body diagram of B. On this one 120 Newton force is acting and on this one 300 Newton force is acting. If you assume here maximum 30 Newton and on this one backward 30 Newton, what will happen? So the acceleration of A again it will come 9 meter per second square, and the acceleration of B it will come 330 by 20, that will be 16.5 meter per second square. Now again here will be the relative acceleration and friction force also acting in this direction. So that is not possible. So we can say now it is not possible. So what can happen? They can move together. So let's assume they are moving together. When they are moving together, let's say it's a A, it is a B. On this one force 120 Newton, on this one 300 Newton. So F net that is acting is a 420 Newton and total mass is a 10 plus 20 into we are assuming they are moving together, so they have a same acceleration. So acceleration is equals to 420 by 30. That will be 14 meter per second square. Okay. Now we'll try to find out the value of friction. So what we'll do, we'll take any diagram, any one object, either A or B. Let's take A only. So let's say the 120 Newton force is acting here, and let's say F is a friction force that is acting here. Okay, and we can say net force that is 120 plus F is equals to mass into acceleration. What is the mass? Mass is nothing but 10 and acceleration is 14. If you solve this one, you'll get value of F is equals to plus 20 Newton, right? So you'll get this friction force in forward direction. The acceleration of this one is 14 meter per second square and acceleration of this one is also 14 meter per second square. And this time also it is a static friction and that is acting is a 20 Newton. But this time it is acting on block A in forward direction. Now let's take another case. Now when this force is 330 Newton. Again you have to find what is the acceleration of A and acceleration of B. Let's solve it again now. How we'll do it again? We'll make a free body diagram of block A. On this one 120 Newton. This is the block B. On this one, let's assume this force is acting is 330 Newton. It is given to us, and now we have already understood like friction force is going to act on this one as a forward direction and on this one in a backward direction. Either you can assume this thing or you can assume as we have done in the previous. So let's assume the maximum friction is acting, so it is 30 Newton and this friction is also 30 Newton. So what we can see here, net force that is acting on block A is what? 120 plus 30, that is 150 Newton, and that is equal to mass A into acceleration of A. So if you solve this one, you will get acceleration of A is equals to 15 meter per second square. And similarly, you do the same thing on block. So the net force that is acting on block B is 330 minus 30 is equals to 20 into acceleration of B. If you solve this one, you get acceleration of B is equals to 15 meter per second square. So is it possible? Yeah, it is possible. When acceleration of A is equals to acceleration of B, means there is no relative motion. So in this case, what is happening? Our friction force is acting and it is acting at a maximum value. And this time this friction is again static friction. So what we can do here, we can put this value in the table again. So it will be 15 meter per second square. It will be 15 meter per second square. And again static friction, and it is at its maximum value. Now let's take again last case now 360 Newton, and again you have to tell the value of acceleration of A and acceleration of B.
Sir, but I have one doubt in this. So why do you change the direction of force in A?
Yeah, you can do like the previous one also. Like if you want to do like previous one, na, what we can do here? Let me take in that case also, na. So what we can do? We take this block A and block B. On this one, there is a 120 Newton, right? On this one, there is a 30 Newton here. So on this one, there is a 330 Newton, and 30 Newton is acting in this direction. So if you take the acceleration of A, it will again come 1 meter per second square. And if you find the acceleration of B, it will be 360 by 20. That will be 18 meter per second square. So now we know our relative motion is happening in this direction, and friction force is also acting in this direction. That what we have assumed.
Yes, sir. Sir,
So
acceleration of A is 9.
yeah, it's a 9 meter per second square, right? So what we can see here, it is again not possible, right now.
Yes, sir.
So we can assume they are moving together. और ये जो मैंने आपको किया ना ऊपर वाला, this can also you assume, not a problem.
Okay, sir.
आपको
Yes,
सिर्फ वो
sir.
केस बनाना है if it is satisfying your condition ना, like relative motion and the friction force, they should be in opposite direction.
Yes, sir.
Okay. So now let's solve the case number 8. So F is equals to 360 Newton. So what we'll do, we'll make a free body diagram block A. On this one, the force that is acting is a 120 Newton, and let's make the free body diagram block B. And on this one, the force that is acting is a 360 Newton. Now, in the previous example, we have understood like the friction force will act in backward direction on block B because it reaches to the maximum value. So again, you can take the friction force on block B in backward direction, or you can follow the same way. What you can take the friction force maximum on this one as a 30 Newton and on this one as a 30 Newton. So you'll get acceleration of A is equals to 9 meter per second square, and acceleration of B is equals to 390 by 20. So you will get how much? 19.5 meter per second square. So again, relative motion is happening in this direction, and friction force is also acting in this direction on block B, which is not possible. So again, what we'll do, we'll take the case when they are moving together. So let's take it's a B. Here it's a force 120 Newton. Here it's a force is a 360 Newton. So when we going to take, they are going to move together. The net force that is acting is 360 plus 120 Newton, right? And it is going to be 480 Newton. And it will give you mass into acceleration. So mass of both the block is 10 plus 20 is 30 into A. So you'll get acceleration is equals to 16 meter per second square. Now we'll try to figure out the value of friction. So if you see the block A, on this one, 120 Newton force is acting in this direction. And let's say the friction force, the value of friction force is F. So we can say 120 plus F is equals to mass into acceleration. So mass of this one is what? 10. And acceleration is 16. So you'll get the value of F is equals to 160 minus 120. So you'll get value of friction force as the 40 Newton. Again, we have calculated initially the maximum value of friction that is possible is mu into n. The value of mu was 0.3 and the value of n was 100 Newton. So maximum possible value was 30 Newton. So again, this case also not possible. Now we'll take the third scenario in this case. What is that case? Let's assume it is block A. On this one, 120 Newton is acting in this direction, and friction force is also acting in this direction. So if you solve this, you'll get 150 is equals to mass is 10 and acceleration of A. You'll get acceleration of A is equals to 15 meter per second square. And let's say on block, the friction force will act in backward direction. That will be 30 Newton. So we'll get F net on B is equals to 360 minus 30. That will be equal to 330 Newton. And it will be equal to mass into acceleration. So mass of block B is 20 and acceleration of block B that we'll find out. So acceleration of B will be 330 by 20. So it will be 16.5 meter per second square. So this time our relative motion is happening in this direction again, and the friction force is acting on B in this direction. So is it possible? So it is possible. So what will happen in this case? We can say acceleration of A is 15 meter per second square. Acceleration of B is 16.5 meter per second square. And this time the friction that is going to act is a kinetic friction. So now what we'll do, we'll draw the variation of friction with the application of the force. Okay. So what we'll do, we'll draw the one line that is our x-axis. On this one, we'll take the applied force, and this is our y-axis. On this one, we are going to take the value of friction force, and we are considering the block B. So we are doing this thing for block B first, or we'll do for both the block. So let me start with block B. So what happened initially on block B, the kinetic friction is acting, right? You can see here. And what is the direction of kinetic friction that is acting? Is forward direct, and it is at maximum value. So when the value of force is 0, the kinetic friction was maximum. We can say this maximum value, and it was at 30 Newton. Up to which value? Up to 150 Newton. Then what started happening after 150 Newton? From 150 Newton to 330 Newton, or you can say till 240 Newton. So let me draw here point 240. At 240, friction force was 0. So means the friction was decreasing and our friction was static at this in this range. Then what happened from 240 to 330? So let me draw again one point here. So again the friction is changing its direction and it's moving in negative direction. At this point 330 Newton, the value again reached to the maximum. It's a minus 30 Newton on block B. Then what is started happening after that? Again sliding will happen. So the friction force will be constant. Is this graph is clear?
Yes, sir.
See, if we draw the same graph for block A, so what happened? Initially, the friction force that was acting is negative. Then it will start decreasing. Then it will change to the positive, and then it will become constant because we are going to have a action reaction pair. Na? So when it's a action reaction pair means every time this value must be equal. Which value must be equal? This value. So suppose this point and this point are lying on the same line. So what happened? If this value is 20 Newton, this value must be minus 20 Newton in that case.